Okay. Alright, so quadratic function. What's the standard form of a quadratic? What you think is the standard form? Anybody? How do you get the quadratic formula? From where? Alright, so someone's going to answer ax squared plus bx plus c. Okay, standard form, which we called vertex form when we were in Algebra 2. This is a times x minus h squared plus k. Okay, things you're going to be able to find from vertex form. You have to be able to find the vertex. What's the vertex of a parabola? Well, first of all, what's a quadratic or parabola look like? Okay, like a U or an upside down. Okay, the vertex is like the point that makes it symmetrical. So it's like the changing point. So either the very low point or the very high point, depending on what your parabola looks like. Okay, from the formula, it's h and k. H is a minus, so when you take this out, you change the sign. Okay, does anybody remember what axis of symmetry is? What does it mean to be symmetrical? Same on both sides. So it's the line that makes it the same. So your formula is x equals h, because it is a line. It's a vertical line, so it's x equals. Alright, and then you're also going to be able to find your x-intercepts. What are x-intercepts? Where the graph crosses the x-axis. How do you find it if you were to plug a number in? Put 0 in for y. Good. Okay, the directions I'm going to give you are going to be the same direction you're going to see on your homework and the same directions you're going to see on your test. Okay? Okay, so we're going to sketch the graph. We're going to find the vertex, the axis of symmetry, the x-intercepts. In order to do that, we're going to have it in standard form. They call it standard form, same thing as vertex form first. Okay, how you know if it's in that form? You can either have the parentheses or the x term is missing. So this is already in standard form. This would be the same thing. It's just they didn't put the 0 in there. So if there's the 0, they just leave it out. So this is already in standard form. Okay? So if I want to find my vertex, I take the number that's subtracted from x, and I take the number on the outside. Well, if nothing's subtracted from x, that number is 0, so my vertex would be 0, and my number on the outside is negative 5. Okay, the axis of symmetry has to be x equals, because it's a line, and the number that you use is the x number in the vertex. So this would be x equals 0. Okay, then to find your x-intercepts, we're gonna set y, we're gonna put 0 in for y, so I'd have 0 equals x squared minus 5. How would I solve that for x? Add 5 and what? Square root. Okay, what happens when you're solving equations and you take the square root? Plus or minus, good. So I have 2 x-intercepts. I have positive square root of 5 and negative square root of 5. If you put x-intercept and then you put that, that's totally fine. Or you can put these as points. Okay, I'm assuming most of you will just put x-intercept and put the number, but if you want to put them as points, you can. Okay. Okay, then we also have to graph. Graphing, I would make it as easy on you as I can, if it was me. So, I'm not going to require that you graph every single thing that you found. What I would tell you to do, this is what I think would be the easiest, is to plot your vertex. So my vertex is 0, negative 5. Okay, then I would make a little t-chart, a little table, and I would pick a number on each side of the vertex. Since it's symmetrical, when you plug that number in, the y value you get should be the same y value for the other one. So like I would plug in 1 and negative 1. Well, 1 squared is 1, minus 5 is negative 4. That means I should get the same thing when I plug in negative 1. Well, if you want to check, negative 1 squared is 1, minus 5 is negative 4, you do. Okay, I'm not going to make you plot the axis of symmetry. I'm not going to make you graph the zeros or the x-intercepts. This is what I think would be the easiest. Just pick a point on each side. I guess it should probably go through the dot. Okay, and graph.
How did you get the vertex?
The number, so the numbers come from in here, not here. So it's subtracted from x is 0, and then my k is the number on the outside.
Oh. And why did you pick 1 and negative 1?
Because they were on each side of the vertex. So I pick a number on the right and a number on the left. You can pick any, I just pick the one closest to it. Okay, if it is not in standard form, we have to put it in standard form. Okay? And how you do that is pretty much like completing the square. Okay, now the difference between this part and when you solve by completing the square, when you solve, it's equal to 0. These aren't equal to 0. So everything has to stay on the same side. So I'm going to have to add and subtract everything on the same side instead of adding on both sides. Okay. So I'm going to talk you through the steps. You might want to write down what the steps are when I say them. So this is not in standard form because it has an x. So your first step is you're going to group the first two together. So you group the first two together. Okay, second step is you're going to factor out a. Okay, a is the number in front of x squared. And you only factor it out of the part that's in parentheses. So what's my a on this one? Negative 1. So I'm going to factor out a negative 1. Then that changes my parentheses to be x squared minus 2x. That 5 that's on the outside, nothing happens to it. It's just the part that's on the inside. Okay, then you're going to complete the square. How you complete the square is you're going to take a half times b. Well, b is negative 2. And we're going to square that. So a half times negative 2 is negative 1. Negative 1 squared is 1. Everybody with me so far? So we grouped the first two, we factored out A. Now we're going to take a half of B and we're going to square it. This number gets added on the inside of the parentheses. And then it's going to get subtracted on the outside. When you subtract it, you have to multiply it by the number you factored out. So what number did I factor out? Negative 1. Okay, here's why you do this. Because when you're adding it on the inside, it gets multiplied by that negative 1. So when you subtract, you have to multiply by that number. This is whatever number you factored out. Okay, so if I talk through the steps again, we grouped it together. We factored out A. We did a half of B squared. And then our fourth step, we added it on the inside, subtracted it on the outside, and we multiplied by A. That's how we factored out when we subtracted it. Okay, your fifth step. This is now a perfect square. So I have a negative 1. I don't know if you remember the shortcut from when we did the solving, but this half of B number is the number that goes in there with your X. And then I simplify the outside. Well, the outside would be 5, and that's going to turn into a plus 1 because negative 1 times negative 1 is positive. So this would be plus 6. Okay, we have to do that before we can do the rest of it. So now we can find the vertex, the axis of symmetry, and our x-intercepts. Okay, so vertex, when we take this number out of the middle, whatever's in parentheses, the sign changes because the formula is minus. So my vertex is going to be positive 1, positive 6. Okay, so this, whatever this is, when you pull it out, changes. It didn't change it right here because it was just 0. 0 doesn't have a positive or a negative. Okay, then our axis of symmetry would be x equals 1. Okay, then to find your x-intercepts, we're going to put 0 in for y, and we're going to solve this. Okay, so to solve it, I would need to get the square by itself. So I would subtract 6. Okay, and then I would divide by negative 1. So I have 6 equals x minus 1 squared. Okay, then you're going to take the square root. So I have plus or minus the square root of 6 equals x minus 1. And then I would add 1 to both sides. Okay, is 6 a perfect square? No. So I can't simplify that. So my x-intercepts are 1 plus square root of 6 and 1 minus square root of 6.
What were the fourth and fifth steps for the first?
So we grouped, factored out. Okay, so this number, whatever your half of b squared, you're going to add it on the inside and subtract it on the outside. And when you subtract it, you have to multiply by a. And then your fifth step is you make this a perfect square. Yes?
So you only multiply by if you have to subtract on the outside?
You always have to subtract this number, and you always have to multiply by a. Now, what if your a was just 1? It's not going to change your number, right? But you still have to multiply, because if you're adding on the inside, but when you subtract, that number always gets multiplied. Okay? Alright, what other questions do you have on number 2? I know that this is the hardest stuff, being able to put it in, oh wait, we haven't graphed it yet. Sorry. How do I know this one's gonna be upside down? Anybody know? Okay, if there's a negative in the front, it's gonna be upside down. If the number's positive in front, it's gonna go straight up. Okay, if I pick a number on each side, so my number was at 1, so I'm gonna plug in 2 and I'm gonna plug in 0. Okay, and you should get the same y answer for both. So if I plug in 2, 2 minus 1 is 1, 1 squared is 1, times negative 1 is negative 1, plus 6 is 5. And if you plug these numbers into the original, you should still get the same answer. So that means when I plug in 0, I also get 5. Because they're symmetrical. So I'm going to plot those points. And then this goes down. Alright, we're going to do one more of these. I know how much you love fractions. Alright, is everybody good on this one? Yeah? Okay, so we're going to do the same steps. So first step is you group the first two together. And I want to factor out A. So my number in front is 1/4. So I'm going to factor out 1/4. So that's going to give me x squared. Now when you're factoring something out, it's like you're dividing by it. So when I take negative 2 divided by 1/4, that's negative 8. If you divide by a fraction, it's the same thing as multiplying by the reciprocal. Okay, and we leave the last part alone. So then we're going to take a half times b, so times negative 8, and we're going to square that number. So a half times negative 8 is negative 4. Negative 4 squared is 16. So I'm going to add that on the inside. Okay, what am I going to do when I subtract it on the outside? Good, multiply it by 1/4. You're always going to multiply by whatever you factored out. Okay, then this becomes a perfect square. So install the 1/4. What's going to go in my parentheses? X what? Minus 4, good. So x minus 4 squared is this number right here. Your half of b is the number that goes in there. And if I simplify this, that would be negative 16 minus 4. Not negative 16 minus 4, negative 12 minus 4, which is negative 16. Okay, what would my vertex be? Not all at one time.
4.
4,
Negative 16.
negative 16, good. You always change the inside number. So what if that was a positive? What if this was x plus 4?
Negative 4.
Then this would be negative 4. Okay, you always change. The one that's not in parentheses always stays the same. And this is going to be true when we do conic sections, which is next semester in trigonometry. Same thing. When you take something out of the parentheses squared, the sign changes. Just like we did circles. You pulled it out, it changed. Okay, axis of symmetry would be x equals 4. And then to find your x-intercepts, put 0 in for y. solve. So first thing I do is add 16. I have 16 equals 1/4 x minus 4 squared. Okay, get rid of the 1/4, so we're going to multiply both sides by 4. So I have 64 equals x minus 4 squared. Okay, and then I get rid of the square, we're going to do square root of both sides. Okay, square root of 64 is perfect, so it's plus or minus 8 equals x minus 4. And then I would add 4. Okay, since this is perfect, don't leave it 4 plus or minus 8. Solve that out. 4 plus 8 is 12. And 4 minus 8 is negative 4. You want me to graph this one too? Yeah? Okay. I'm running out of space on the video.
So will the axis always be whatever when we did 1.5 times b, like if we got -4 for this one, will the axis always be that number but the opposite sign?
Yes, because that's the number that goes straight in here, and then when you pull it out, it changes. These numbers are always the same. The only thing different is the axis is aligned so it has x equals in front of it. Yeah. Okay, I'm going to count by 2s on x and y so I can fit it in the screen. So I would have 4, negative 16, 4, 6, 8, 10, 12, 13, 16. And then for my t-chart, since I'm counting by 2s, I'm going to plug in 6. I'm going to plug in 2. And remember, they should get the same answer. So 6 minus 4 is 2. 2 squared is 4. Times the 4th is 1. Minus 16 is negative 15. So I would have 6 negative 15 and 2 negative 15. So this one's going to be kind of like a fat one, wide one.
How did you get 6 and 2?
Just, you need to pick a number on the other side of your vertex. And since I counted by 2s, that's why I didn't use 5 and 3. It doesn't really matter what you use as long as you pick a number on each side. If you pick them equidistant, they'll be the same number. Your y's will be the same. Excuse me. Alright, that will take you all the way through your graphing. So now I'm going to show you how to do the second part, which is a lot easier. Promise. See why I said you guys probably wouldn't watch the video? Okay, you're going to be given a vertex, you're going to be given a point, and your goal is to write an equation that's in standard form, so it looks like this. Except for we don't want A, H, and K, we want to put numbers in for those. Okay, well if you have the vertex, which you will for all these problems, what letters go with the vertex? H and K. So this is H and this is your K. So go ahead and plug those in. When I plug those in, I have f of x equals A times Okay, x minus -2, which turns into x plus 2 squared. And then plus k, so plus 5. Okay, so I'm missing my a. Here's how you find a. You're going to take your point, and you're going to plug those in for x and y. F of x is the same thing as y. And we're going to find a. So I would have 9 equals a times 0 plus 2 squared plus 5. Okay, well 0 plus 2 is 2. 2 squared is 4. So I have 9 equals 4a plus 5. Okay, how would I solve that for a? Subtract 5, so I have 4 equals 4a. And then I would divide by 4. So I have a equals 1. So you already have your equation. All you do now is you take your a and you plug that in. So it'd be 1 times x plus 2 squared plus 5. Which I think that's way easier than graphing. Alright, let's do one more example. And then I'll be done. Yep. Okay, so the first thing you want to do is you want to take your vertex and plug it in for h and k. So I have f of x equals a times x minus 3 squared plus 4. Okay, and we're going to take our point, plug that in for x and y. So I have 2 equals a times 1 minus 3 squared plus 4. Okay, and we're solving for a. So 1 minus 3 is -2. -2 squared is 4. So 2 equals 4a plus 4. And then I would subtract 4. So I have -2 equals 4a. Divide by 4, so a equals -1/2. So that means the equation would be f of x equals -1/2 times x minus 3 squared plus 4. Okay, so these last two are how you do 44, 46, 48, and 50. Alright, thank you. Good stuff.